Since a vampiric institution does no work on its own, people working for it, imagining themselves as part of it, tend to see the workings of the Earth system from that viewpoint, and from the point of view of something that takes more account of heat rather than work, which are both components of the total energy content of a system. According to the first law of thermodynamics, the change in energy of the system is dependent upon two components, the heat component and the work component. The work component, I think, is the least well understood. Vampires are primarily concerned with how much radiation is hitting them and not how much work they're doing. So, work can affect the system in two ways. If it's work done by the system, it can make the overall system cooler because it's a substitute for heating. If it's work done on the system, then it can make the system warmer. The work done by the system tends to be done on carbon dioxide and water, lifting them up to make the roof of the model oven, or pulling them back down again as rain, snow, rivers, glaciers, and so on. Now, the work done on air is quite an important component of allowing it to be heated. If you put radiation onto a parcel of gas, or put it in contact with warm ground and so on, it doesn't necessarily have to get warmer. If we could imagine a setting where there was a rock with gas sitting next to it, and it was a very small rock, exerted very little gravitational pull, then the gas could be heated and would not necessarily have to warm up. It would simply expand instead. It would increase in volume rather than temperature, according to the ideal gas law. And under that imaginary setup, then the gas could expand and expand until it drifted away from the rock altogether. If this happened with the Earth, we wouldn't have an atmosphere anymore. So there has to be a partial restriction on the capacity of the gas to expand in order for it to be heated. So gravity is always playing something of a role in the heating of the gas. In a normal oven, once you get the oven constructed, it doesn't take much to keep the walls in place. There's an energy cost for building the oven, but overall it's worth it to maintain the heat inside it. Now imagine if you had an oven whose roof fell apart every few days, and you had to keep rebuilding it that regularly. Say, equivalently, you had a house with a roof on it to keep the heat in, but the shingles would fall off and decay every few days, and you'd have to call in a team of workmen to rebuild the roof every few days, and as they did so, their bodies would have to burn fuel to make heat, to allow their arms and legs to move and do the work necessary to pound the nails to put the shingles back on the roof. After doing that 2 times a week for a while, you might start to think that, maybe all the heat that's being expended by all these workers to allow them to move and repair my roof is greater than the amount of heat I'm holding in by having to repeatedly repair the roof. And that's the problem when you make a roof over the earth that's made out of gases. That's the premise behind assuming that the earth works like an oven with walls made out of gas, or greenhouse gases as they're called. Water and carbon dioxide have to be put into the atmosphere to make the presumed roof of the oven that will hold in escaping radiation. But in order to do so, that requires an enormous input of energy on a regular basis, because the water is always trying to fall out of the atmosphere, and it takes energy to keep putting it back up.